Hello guys, welcome back to my channel. My name is Sabo, but I'm popularly known as Dr Sammy. Now I'll be teaching you NTH. What will I be teaching you on NTH? I'll be teaching you the topic set. Now, what will we be discussing under sets? We'll be discussing set specification, and then not only set specification, I will teach you subset, power of set, universal of set, and complement set. Also, we'll be doing set operation and Venn diagram. So these are the contents I will be teaching you under the topic set. So trust me, once I am done with this topic with you guys, you will feel the simplicity in this topic. So to encourage and then support our brand, you kindly do one thing for me: you subscribe to my channel. If you know you want to keep watching this video, just do that. So I'll wait for you to do that. Okay, thank you for subscribing to my channel. So now I'm taking down to business now, which is set. So what is set? Set is a well-defined collection of objects. Now what do I mean by set? Look at it. Set is a well-defined collection of objects. Collection of objects. Now set is a well-defined collection of objects. So what do I mean by set being a well-defined collection of objects? Now let us take mathematical set as example. Now your mathematical set is an instrument in which all the sets are used for what? Mathematics work. So we gather all the items together and we call it what? Mathematical set. For instance, spoon set. All the utensils which we use as spoon, we call it what? Spoon set. So therefore, all the objects that have common features that we can group together to do one particular things are called what? Set. For instance, again, your kitchen utensils, that is your bucket, anything you use in the kitchen, that utensils is also called what? A set. So that's why I say a set is a well-defined collection of objects. Now, what do I do again? I will teach you another thing which we call what? Set specification. Now, but before we go to set specification, I have to teach you how to what? Denote a set. Now, how do we denote a set? Let's say that we have set A. Now, if you are talking about set A, you will represent it with a capital letter. So set A, this capital letter. Now, if you want to talk about the items in that set, so it will just be, you use a curly bracket to enclose the items in that set. So this is how the curly bracket looks like. Let's say the elements or members or items in set A is 1 to 5. This is 1, 2, 3, 4, 5. Then you close it like this. Are we together? So, and this is the what? This is the set represent with capital letter A, and these are the what? Items or members or objects. Now let's take another instance. Let's say this is set A and the member is A, B, C, D. Now take note, members or items, if it is alphabet using, you represent them with what? Small letters. So please take note of this. It is very, very important. Now, since you know how to do what? How to denote a set. Now, take it to what? Set specification. Which is the next item I have under my content. Now, I will teach you set specification. Now, the first set. Now, hello, welcome back. Actually, so set specification. Now, we have some. Set specification is just how to what? Denote a set. So now the first set specification is called list notation. So list notation is just when you what? Represent a finite set with what? Comma. So we call it what? We call it list notation. For instance, let's say set A is just 1 to 10. It's not large, so it's finite set. It's something we can count. So therefore, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now, if you want separate the items with comma, look at it. We call it what? We call it list notation. Please take note of that. Now, the next one is average notation. Now, average notation is used to denote infinite sets, like sets that you cannot what? You cannot count. For instance, let's say sets. Let's say it's just like this. 1, 2, 3, 4, uncountable. Are we together? So this kind of denotation is called what? Average notation. So now the next one is what? Predicate notation. All this specification you just have to write the set. predicate. Now predicate is just when you denote a set with an equation. Like for instance, if you say x is just what? X less than, oh sorry, it's just 2 less than x less than 4 or less than equal to 4. So this kind of denotation is called what? It's called predicate notation. That is that they are telling that the x value is from 2 to what? 4. 2, 3, 4. So this is the way of writing what? Predicate. This will represent what? The sets with member with what? With equation. Now the next one is what? Recursive. So recursive is just using a general properties to what? To classify a set. For instance, if you say, now I'm going to recursive now, this is for predicate. Now recursive, let us say A is what? All, oh no, sorry, let's say even number first, or odd number. So A being all odd number, are we together? We just use this to what? To represent all the numbers that will be in what? A. So this manner is called recursive notation. So you know even numbers 2, 4, 6, 8 and co. Are we together? So this way of writing a set is called what? Recursive. And when represented with equation is called predicate. When you list an infinite set that does not have ending, it's called what? Abridged notation. When you list a set that has an ending of that is finite, is called what? List notation. So we are done with this subtopic part. Now the next part is subset. Now subset is just a set under another set. Now for instance, if you have set A to be this 1, 2, 3, 4, 5 and set B to be just 2 and 3. Are we together? Now look at this set B is under what? A. You can find B in A. So B is a subset to what? To A. So that's just the meaning of what? Subset. So please take note of that. Now the next thing is what? Power of a set. Power of a set is just simply how many ways you can write the what? The element in that set. For instance, if you have A equals to what? 1, 2. Are we together? Now this is just what? How many ways can we write what? This set. So now to get the power of a set, there's a formula we use, which is what? 2 raised to power what? N. So power of a set, P. Now this is the formula we use. So if they give you this set and then they ask you that how many ways can you write this set? Or what? Calculate the power of a set. It is very simple. This N denotes the numbers of elements in the word set. Now what's the number? Let's count. 1, 2. So our N is what? 2. So to calculate the power of set, it will not be what? 2 raised to power 2, which is what? 2 raised to power 2 means 2 times 2, which is what? 4. So the power set is 4. Now I'm moving down to what? Universal set. Now what's the universal set? For instance, let's just say we have set A to be 1, 2, 3 in curly brackets. B should be what? Let us say it's 2, 6, 7 in curly bracket. Okay. Then we see and then we now have set 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now if we have these 3 sets, now take note. A and B is subset of U. Are we together? You can find A and B in U. So it's subset of U. So the set that contains all other sets under discussion is called what? Universal set. It's just like the egg. Are we together? It's just like what? The egg. So this U now is a universal set because it contains what? A and B. So that's universal set. Now from this, let me explain what we call complement of a set. What's complement of a set? Now if we remove this subset from this universal set, the remaining set in the universal set is called complement of A. Now let me do this. Now let's remove A from universal set. I cancel it out, I cancel it out, I cancel this out. Therefore, what's remaining in U? 4, 5, 6, 7, 8, 9, 10. So that 4, 5, 6, 7, 8, 9, 10 that is remaining now is our complement of A because it is A we remove in that universal set. So the complement will now be 4, 5, 6, 7, 8, 9, 10. So you can try this. Now try this, try this. Just pause this video and try this. Okay, now let me do it. B, now to find the complement of B, I will have to remove this value from this place. So now I will clean and write it very well so that I can remove from beginning again to get the complement of B. So I will cancel 2 out, I will cancel what 6 out, and I will cancel 7. So the rest value in U will be complement of B, which will now be what? 1, 3, 4, 5, 8, 9, and 10. So this is complement of what? B. And see how we denote complement. You just write C on top of the set. You just write C on top of the set. Or you can write A prime, B prime. This denotes what? Complement. You either write it like this or like this. Write it like this or like this. So that's that. Now the next part is what? Set operations. Set operations. The next part is set operations. Now, set operations. Under set operation, we have union, we have interset, we have union, we have interset, we have set difference. 4, we have what? Symmetric difference. Symmetric difference. So these are the what? Set operations. These are what we can do with what? 2 or more sets. This is how we can solve 2 or more sets. So what do I mean by union of a set? Now, if you have 2 sets and you combine everything together without repetition, it is called what? Union set. What do I mean by this? Now, let's say I have set A is 1, 2, 3, and I have set B is what? 1 is just 4, 3, 6. Now, the union set, the symbol for union set is just what? Is U. Are we together? So now take note of this, and then if I'm now have to find A, U, B. So anywhere you see U, know it denotes what? Union set. So that is, I have to combine the 2 sets without what? Repetition. How do I do this? I combine the 2 sets. We have 1, 2, 3 in the first set. And the second set, I will combine it with the first set, 4. But 3 has already existed, so I will just go cancel it out. I'm not rewriting 2 things. So I move to the next number, 6. So I combine these 2 sets without repetition. It is now called what? My union set. So this is my curly bracket. This is my curly bracket. Are we together? And this is 4. So I combine it without repetition. 1, 2, 3, 4. Then you don't need to write this 3 again, 6. So this is my union set. Now, the next part is intercept. Let me quickly explain intercept. Intercept is denoted by A. Are we together? So you just A intercept B, which will now be. Now, what does intercept mean? When you see N, it means intercept. Intercept is just like when you have 2 sets and you pick the common one. Common one. So what's common in A and B? It is what? 3. So 3 is what? Intercept. Now set difference. What is set difference? Now set difference is just, let me show you what set difference is. For instance, set difference is just like when you take the difference between 2 sets. Now look at set difference. A minus B is a set difference. Difference is minus between 2 sets. Now, what does this mean? A minus B. Where is the minus attached? The minus is attached to what? B. So it means move B from A. So removing B from A is that you will cancel out the common one in B. You cancel out the element you find in B that is in A. You cancel it out. So remove B from A. So removing B from A, what is the B? 3. You want to remove 3 from A. So you cancel it out. Do you have any set here that you have to remove in A? No. So therefore, the remaining set in A is your set difference, which is your 1, 2. Now let me explain this. Remove B in A. Now your B is 4, 3, 6. Now you check the B that you can remove in A. It is what? 3. Assuming there is 4 here, we will remove 4 too, but there is no 4. It is only 3 that we can remove in A that is in D. So cancel it out. Write the remaining A, 1, 2. That is the set difference. Now symmetric difference is what? Denoted with this symbol triangle. So it is just, if they give you A triangle B. This is how to find the symmetric difference, because this symbol denotes symmetric difference. We just do A minus B union B minus A. Are we together? So if you do this, you already know, you do the set difference of this, do the set difference of this. Now take the union, you get your what? You get your what? Symmetric difference. Now the next thing you have to take note of again under set operation is called cardinal number. Now cardinal number is just where you denote the set like this. For instance, if you have this set A equals to 1, 2, 3, and you have to find the cardinal number, it means you should count the number of elements in that set. And cardinal number is denoted by n, number of elements in set A. This is how we denote cardinal number. If it is set A to be number of elements in set B, n means number of elements. So number of elements in set A, you just count 1, 2, 3. 3 is the cardinal number. So that is just that. Now, last but not the least, the next one is what? Venn diagram. Venn diagram. Now, a Venn diagram is just a representation of set with what? With a triangle and circle. So, if you represent a set with triangle and circle, it is called Venn diagram. Venn diagram. So this triangle is called the universal set. It denotes universal set. And the circle, they denote the what? Subset. So this is the what? This is universal set. Now this place, this shade here, denotes the intersect between the two sets. So this place I color denotes the intersect. So that is just it. And everything here denotes the union. So that is everything from here and here denotes the union, and this place denotes the what? Intersect. Now thank you for watching. Please like, subscribe to my channel.